Hello student, welcome back for the one more session. This is Vasan Nayak from Canada Engineering College. In this video you will study 8255, that is Programmable Peripheral Interface. In the previous video we studied how we can interface different types of sensors and actuators to the embedded system, just like stepper motor, keypad, push button switch, all those things we studied. So in this video, we'll see Programmable Peripheral Interface. So, programmable peripheral interface devices are used for extending the I/O capability of processors or controllers. Normally, controller will have sufficient number of I/O capability, but in case of processor will not have sufficient number of I/O capability. So that's why what we do is we can expand the I/O capability of the processor or controller by using 8255A. So 8255A is a programmable peripheral interface which supports 24 I/O pins. So these I/O pins are grouped like port A, port B and port C. All are 8-bit port A, port B and port C. In that, port A and port B are 8-bit port C is further divided into two 4-bit port named as C upper port and C lower port, like C upper port and C lower port. 4-bit for C upper port and 4-bit for C lower port. Now, this 8255 is called a programmable peripheral interface. Why it is called as a programmable peripheral interface? Means it has got something called a control register which holds the configuration for port A, port B, port C. So you can configure, you can program that control register to change the configuration according to your need. That's why it is called as a programmable peripheral interface. It is called as a programmable peripheral interface. So now this control register is a 8-bit register. Now control register is a 8-bit register. So here you can see this register will be there inside the 8255. This register has got 8 bits. So the 8-bit 8-bit in this case it is 7th bit because we starts with 0. If it is 0, then your 8255 will remain in bit reset mode. If it is a 1, it will remain in simple I/O mode, the I/O mode. So let me take you to that diagram. So here you can see students, there are two modes for 8255 that is decided by bit 7 of the control register. Bit 7 of the control register, if that bit is 0, then it acts like a bit reset mode. That 8255 acts like a bit reset mode, bit set reset mode. The bit, otherwise it will act like a input and output mode. We will see that one. What is bit reset mode? This bit set reset mode is used to set or reset bits of the port C only. So bits of the port C only. For making this one, that is to convert 8255 into bit reset mode, you have to change the value of the 7th bit to 0. If you make the value of 7th bit to 0, this indicates your 8255 in bit reset mode, bit set reset mode, and you can change the bits of the port C. How you can change the bits of the port C? So when you make this bit, that is this bit 7th bit is equal to 0, this indicates it 7th bit is equal to 0, this indicates it is in the bit reset mode. Then bit D4, D5, D6, let it be don't care. This is a don't care condition, it can be anything. Then we use here bit D1, D2, D3. suppose bit D1, D2, D3 is equal, this combination is 0, 0, 0, then it will set the first bit, 0th bit of the port C. If it is a 1, 0, 0, 1, it will set the first bit of the port C. 0, 1, 0, it will set the second bit of the port C. Suppose it is 1, 1, 1, 1, it will set the 7th bit of the port C. We know port C is a 8-bit port and it is further divided into two 4 bits like C upper and C lower. And to make a particular bit either 0 or 1, you need to use this one. If you make particular bit is equal to 0 or 1, then you need to use this value D0. So suppose if you want to make the particular bit is equal to 0 or 1, you need to use this one. For example, I will use this value D3, D2, D1 is equal to 0, 0, 1, 0. When you use 0, 1, 0, then this will, this is the third combination. The first combination is 0, 0, 0. Second combination is 0, 0, 1. So first combination you will set bit 0 of the C port C. This combination will set bit 1. This combination is for bit 2. So what this will do, this will either set or reset the bit 2 of port C depending on this one. If you keep this as 0, then this second bit of port C is 0. If you keep this as 1, second bit of the port C will act like a 1. So in this way you can change this one. Now so other than that, when the 7th bit is 1, then it acts like a input output mode. So you can see here input output mode. 8255 acts like input output mode. So what is that input output mode? In the input output mode, once again 3 modes are there: mode 0, mode 1 and something called as mode 2, mode 2 or mode 3. So mode 0 means a simple basic input output mode. All port A, port B, port C acts like input output. Mode 1, port A and port B can be used as input output. Port C are used for handshaking. Like handshaking is the procedure. It is used before transmitting the data from one end to the other end, so that both sides of the transmission will negotiate certain condition before transmitting the data. That condition is called as a handshaking condition. So third one is mode 3. Here port A can work, but port B can be either in mode 0 or mode 1, and port C are used for handshaking. Port C can be used for handshaking. So input output we have 3 modes: mode 0, mode 1 and mode 3. Next, so now we will move to the diagram. So here you can see, as I said, this bit is 1. That indicates it is in simple IO mode. It is not in bit reset mode. It is in simple IO mode. So as I told earlier, 8255A is a programmable peripheral interface. This contains a control register. Control register holds the configuration for port A, port B, port C. In 8255A, we have 24 pins. These pins are divided into 3 ports of 8 bits each. So port A is 8-bit, port B is 8-bit and port C is also 8-bit. But port C is further divided into like C upper and C lower, 4 bits each. So depending on the different types of configuration in the configuration register or control register, this port A, port B, port B can be configured as either input port or input mode or output mode, that we will see here now. So this is simple input output mode. Now we need to see the bit 5 and 6. What about bit 5 and 6? You see when bit 5 and 6, 2-bit 4 combination is there, The first combination is 0 0 means it acts in mode 0. I told you what is mode 0. Mode 0, all the ports acts in simple input output mode, and if it is 0 1 it will act in mode 1. Mode 1 port port A work in simple input output mode. Port B works in so let me repeat, mode 0 all the ports works in simple input output mode. Mode 1 port A and port B can be used as input output mode, input output mode, input or output mode, and port C used for handshaking. And in the mode 3 only port A can work. Port B is either in mode 0 or mode 1, and port C can be work in handshaking only. So this is the combination to select the mode, whether mode 0, mode 1 or mode 2. Mode 0, mode 1 or mode 2. Now we'll start from left hand. So here D0, this bit is used. So total this once again we are classified into group A and group C. Group A deals with the upper port C and port B. Group B deals with the upper port C and port B. Group A deals with the Group B deals with the lower port C and B, and group A deals with the upper port C and port A. So I will take first this bit D0. When this bit is 1, this indicates it's the input mode, and when this bit is 0, this indicates output mode. Similarly, this bit, it is 1, it indicates input mode, and 0, this indicates output mode. This is input or output. What about mode 0, mode 1? So you know what is mode 0. Mode 0 means simple input output mode. Mode 1 means handshaking mode, handshaking. So mode 0, so this one bit 2 is used to configure either mode 0 or mode 1. Mode 0 or mode 1. Once again, let me take you to here. You see in this diagram, mode 0 means simple or basic input output mode. Mode 1 means handshake or strobed mode. Mode 3 means bidirectional mode. So here this acts like a mode 0 or mode 1 depending on the selection, either 0 or 1. That is, one is handshake or strobed mode, other one is simple input output mode. Now bit D3 is used to configure upper port of port C. So here you see this is used to configure port C, upper port C, say PC4 to PC7. When it is 1, this indicates input mode. When it is 0, it will indicate output mode. Similarly, this bit is used to configure port A. When it is a 1 input, 0 output. And here these two bits we know it is used to configure mode 0, mode 1 and mode 2. Here this group you cannot configure in mode 2. This group you can configure in mode 2 also. This group you can configure in mode 2 also. So now we will see some of the examples, so you will understand here. So let me take you to some of the example. So let's see the first example here. This is the first example. So we need to program the control word for simple input output mode for making port A, port B and input port A and port B as input port, and port C upper as upper and port C lower as output port. Port C upper and port C lower as output port. That means here I will take you to this diagram first. So this is the diagram. So our requirement is first one is it should be simple input output mode. Simple input output mode, like it is a simple input output mode. Second one is port A So let me take you to that this one. Port A and port B, port A and port B as an input port. So port A and B, port A and port B as input. This is input. And total port C is output, upper and lower. Port C is output. We want this one. But simple IO mode, like control word for simple IO mode. So what we will do is like you see here. First you have to see the control bit. Control bit is 1. Control bit is 1 for simple it is not bit reset mode, it is a simple IO mode. Simple IO mode, that is control bit should be 1 for a simple IO mode. Then this 2 bit for mode 0. So we should set this is 1 and this 2 bits should be 0 0. You know why it is 0 0. Why it is 0 0. This 2 bit should be 0 0. Because we want to select mode 0, and here also port B also mode 0, port B mode 0. How you select the port B mode 0? Port B mode 0, this bit is also 0. Then both C upper port, like C port, both entire C port should be output. That is, one is upper C port and lower C port is output, and port B and port A as input, 1 here and 1 here. So when you convert this into hexadecimal, this is 9, this is 10019, and this 0010, this is 2, 92 in hexadecimal. 92 in a hexadecimal. So now we'll see, we need to make simple, like simple input output mode. So mode is simple input output. Then we want port A as input. So port A as a input, port B as output. I want port B as output, port C upper as input once again, port C lower as output, and finally here control word you see 98 you should get. So first I will take you to that particular diagram. Here you see, so first simple input output mode. So simple input output mode means this should be 1. You know, this should be 1. This should not be 0, because 0, if you select 0, then it will go into bit set reset mode. Then simple input output mode. Simple input output mode, here you need to select mode 0. So mode 0, that is 0 0 bit, this bit is 0 0. Now we will start from this end, like port C upper is equal to input. Which is port C upper? You see here, port C upper is this one. This should be input. Input means 1. Here should be 1. Then port C lower is 0. This one, port C lower is equal to 0. This should be port C lower is equal to output 0. Other than that, port A input. So port A, you see here, port A, this bit input. Port B output. So this is port B output. And port B is in simple mode, this one. Simple mode. So now if you see this one and this one, you will get 9 and 8, 98. So this is the control word. Now we will move to the next one. So in this diagram you see here how to change the particular bit of port C. For example, I want to change the particular bit of port C. Then I should go to bit reset mode. That is D7 should be 0 and other 3 bits is don't care. And other than that, to set the 5th bit of the port C, I need to use 101 and I want to set that one. To clear the 5th bit, to reset the 5th bit once again 101, I should make D0 is equal to 0. To set the 4th bit 100, this combination should be 100 and 1. To set the 7th bit 111 and D0 should be 1. To set the bit you are using 1, to reset the bit you are using 0, and to select the bit select the bits of port C, you have to use these 3 bits combination. 000 means first bit, 001 means second bit, like that. So this is the control world. Next, so how you can interface 8255 to the processor or controller. You can see the diagram here. You will see the diagram here. So this contains 82C55A, or we call this as 8255, that is programmable peripheral interface. So here this interface, this one we are going to connect to the processor. Why we are connecting this to the processor or controller? In order to expand the capability of IO. That means it has got 24 pins. That 24 pins are classified into port A, port B, port C, and depending on the configuration it works like IO mode, strobed mode, or handshake mode, or bidirectional mode. So now here while connecting, what we are doing is we are connecting 8. So normally 8255 has got or our controller has got 8 data lines. So that 8 data lines are connected to the 8255. Now it has got 8 data lines, this controller, but this controller has got 16 address lines. In order to go for optimized design, in order to save the number of pins, what we are using here is multiplexing. Same data bus we are taking, and using address latch enable, we are converting that as address lines. Same data bus we are taking and we are converting that as address lines, that is A2 to A7, something like that, and we have here A0 and A1 anyway, A2 to A7. Then we will take higher order address bus 8 and A15 and we will generate 16-bit address. So 16-bit address are generated by using a multiplexing technology. That is, it makes use of the same data bus. You know, data bus and address bus cannot be used simultaneously. You know that one. So data bus, it will make use of the data bus and it will convert that data bus. It will use that data bus as address bus. For using that address bus as address bus, I am using latch here 74LS33, and through that latch it is connected to address decoder. The other input for the address decoder is higher order address bus, that is A8 to A15. Like this, it will generate a 16 address lines, 16 address lines, and we have read, write, reset. All these are connected to the microcontroller. In this way, we can interface 8255 to the processor or controller, and we can expand the capability, IO capability of the processor, and this IO is used to connect input output device. So by using this IO pins, we can connect various input output device. So with this student, we have covered all the sensors and actuator device which we use normally to connect in the embedded system. In the next session, we will see what are the different components of the communication interface to the embedded system, such as USB, RS-232, Wi-Fi, Zigbee. All those things we will study in the next video session. Thank you for your cooperation. Thank you.